I am Havarno, and today we will continue our discussion on the chapter of force. We have already looked into the topic of force, torque, couple, and moment due to force and equilibrium of the body. So today our topic of discussion will be center of gravity. Before starting the topic, I want to ask you a question. Do you know what gravitational force is? Or force of gravitation? If two objects having a mass of m1 and m2 are placed at some at a distance of, let's say, d, then both the body attracts each other with a force that is given by F is equal to g m1 m2 by d square, and this force is known as the force of gravity. Every body having a mass wants to attract every other body which is also have some mass. Now the force between these two bodies are being governed by the product of their masses and, let's say, force. Now on which parameter the force will depend? The force is directly proportional to the product of the masses between which the force is acting, and it is inversely proportional to the square of the distance between them. Let's say this is one body having mass m1 and this is another body having mass m2, and the distance between these two bodies is d. Now they will pull each other, they'll try to pull each other towards themselves. So that pull force or that attractive force will be given by, is directly proportional to product of their masses and square of distance between them. Now if we equate them, we have to put a proportionality constant, and the proportionality constant in this case is g, that is the gravitational constant. So in this way we will get the formula for gravitational force. This gives the magnitude of the attraction by which the bodies are pulling each other. So gravitational force is a kind of attractive force. Plus, it is one of the fundamental forces. And it acts between bodies having some mass. This is the scenario of the gravitational force. Now, if we move on to the topic of center of gravity, let us first discuss about what is gravity. Let's say this is Earth and this is the center of Earth, and we all are residing at the surface of the Earth. Let's say this man is having 50 kg. Weight of this man is 50 kg. So weight is nothing but the product of m into g. That means the mass of the body and the gravitational pull possessed by the earth on the body, denoted by g. So weight is nothing but the product of mass into gravity. That means this man is being pulled by earth with a force of 50 uh, this man is possessing a weight of 50 kg on earth. This is due to the gravitational pull of the earth on the man. Now, if we replace the man with a point object, let's say A, the earth will pull this man towards the center. Now, this pulling force, we call it as gravity. Okay. Now, gravity is clear, gravitational force is clear. Now, talking about center of gravity, let us first assume an arbitrary body having a weight of W, total weight of W, let's say. Now, this is the whole body. Now, the weight is distributed all over the body. That means all the particles of the body is constituting to the total weight of the body. Now, if we add all these weights individually, then we will get the total weight. Let's say 1, 2, 3, and infinite. Infinite number of particles are present here. So the total weight of the body is the sum of all these individual weights. Now, all these weights will experience some pulling force towards the center of earth. Now, what is center of gravity? If we take a point in the body around which all the moments of all other forces that has been acting on the individual particles, those moments become zero, then we call that point as the center of gravity, denoted by Cg. Okay, what I have said, the moments in this direction and moments in this direction, that means the algebraic sum of the moments. If equals to 0, we consider that point as the center of gravity of the body. So if we want to define center of gravity, we can define it as if we want to define center of gravity, it can be defined as the center of gravity of a body is the point about which the algebraic sum of moments of weights of all the particles constituting the body is zero. That means the algebraic sum of all the moments of the weights of the particles present in the body is zero. Then we call that point as center of gravity. Now we can treat the whole body as a point mass, having the total weight W, which is W1 plus W2 plus W infinite, and we can study the system in this way, which helps us to understand the concept easily. The entire weight of the body can be considered to act at this point. I am considering the whole body as a point object, and the weight is acting as the same way the actual body is acting, and howsoever the body is placed. That means this will act in the same way no matter what the orientation of the body is. Let's say this body is being oriented in this way, then CG will be in this direction. But when we are taking the body as a point mass, then there is no issue in which orientation we are going to place it. So this is all about center of gravity. Now we will discuss about Now, write some notes first. Now, if we look into these points, the note number one is CG of a body of given mass depends on its shape, that is, on the distribution of mass in it. It changes if the body is deformed. Now, let's say this is a body, a triangular shaped body, and you can observe that the mass distribution over this area is much more greater than the mass distribution of this area. What do you mean by that? The area having the higher mass distribution, the CG will reside in that area. The CG will be at around this point. This is because, what do you mean by mass distribution? The mass present over that area is the mass distribution of the body. So when we are considering this area, when we are considering the uh, total object, then we can see that the mass distribution is dense in the lower part and it is less dense in the upper part. So it can be observed that the CG always resides in the more dense area. Now, the shape factor decides the density of mass present. That's why here it is mentioned that CG of the body will depend on its shape, that is on the mass distribution. And let's say this body, I have deformed the body into this. Now what do you think? Does this will this CG shift from this point to any other point? Yes, you can definitely observe that this CG will shift towards its right. Let's say at this point. So the deformation of the body is leading to the change of position of the CG. Why it is happening? Because the mass distribution is also changing, and CG depends upon the distribution of mass of the body. That's why the CG will change if the body is deformed. Now, point number two says that it is not necessary that the CG will always be within the material of the body. Let's say we have a circular ring. Okay, we all have seen the how a ring light looks like. Let's say this is the ring light. Now, can you say where the CG point of this object will lie? It will not lie in this point or this point or this point, because the mass distribution in the whole object is uniform and the shape is also uniform. So it can be in the body of the object. It is somewhere outside the body. So for this circular ring, we get the CG in its geometric center, which is an imaginary point. There is no physical existence of mass in it. So if we consider the whole ring as a mass ring having a mass of W into the center with having the same mass, same weight W, then it will act in the same manner as the ring light is going to act. So from this example, we get to know that the CG, it is not necessary that every time the CG will reside on the body only. It can be outside the body. Now, according to point 3, by the concept of CG, a body of weight W can be considered as a point object of weight W at its CG. This is what we have learned in the whole center of gravity. Here also, if we are not considering the ring light, we have to consider it as a point object with mass W at the point of its center of gravity. And it will give the same result. So this is all about the points. Note that these are important. Now here is an exercise for you. Let's determine the CG of these bodies. If we consider a circular ring, that means the mass is concentrated at its circumference. This is a ring. The mass is only in the circumference. So it will be as same as that of the ring light case. It will be at the geometric center of the circle. Now, if the radius is, let's say, r, then, or the total diameter, let's say d, then the CG will lie in d by 2. Now, coming into the circular disc, the mass is uniformly distributed over the whole area, whole circular area. For this, it is same as the geometric center of the disc. Now, coming to a triangular lamina. For a triangular lamina, we have to draw perpendicular from all the three corners of the triangle. These are symmetric shapes, so we can determine them by using geometrical symmetry or geometrical similarity or geometrical mass distribution, you can say, because the mass distribution is uniform over these bodies. If I give you a body whose shape is like this, you can determine the exact point by just seeing into it. You have to calculate. Okay, so geometrically symmetrical masses, the CG of the geometrically symmetrical masses can be determined by the figure only. Now, this point is the CG of the triangular lamina. Coming into the rod, let's say this is the length of the rod L, and the dB, let's say it is negligible, that is tending to 0. Then the CG will be at a point which is half the distance of L by 2 of L, that is L by 2. And for a cylinder, it will be at the midpoint of the length of the cylinder L by 2, and also the midpoint of the diameter of the cylinder is D by 2. So this is the CG point of the cylindrical object. Now I am giving you a problem and you will solve it by your own. Let's say the shape is like this. The whole object is composed of three subparts. This length is L, this is also L, this is A, this is A, this is B, and this is C. Now you have to determine the CG of this body. Now let's move into the new point, the method of balance. This is a method of finding the CG of an irregular shaped body by balancing the body. And how do we balance? By suspending it from a point. Now let's say we have a body of this shape and this is the pivot point, or it is free to oscillate from this point. Now when we give a force, let's say we are giving a force in this direction, it will start to oscillate. Now it is freely suspended and after some time it will come to rest. Now when the body will come to rest, then the CG will be acting vertically downward from the point of the center of gravity. So we have to take an object, suspend it freely, give an oscillation, and after it comes to rest, it gets balanced in a position that is center of gravity lies vertically below the point of suspension. The center of gravity lies vertically below the point of suspension. That means it is coming to rest at this point, and at this line of action of force below the point of suspension, the center of gravity will lie in this line at any point it can lie. Now, to get the exact point, we have to determine the let's say we have to determine the exact point of the center of gravity. What we can do is, let's say this is a body having some irregular shape. Take 3 points near to the edge of the body. We name this as A, B, and C. Now, ah, allow the body to suspend freely from point A. Give some oscillation to it. Now it will come to rest at some point. Now extend the line vertically downward at the position of the rest of the body. This is the line of action of the force of gravity. Okay, suspended point A and did the experiment. Now do the same for point B. Suspend it, give the oscillation, and it will stop at some point. Let's say it has come to rest at this point. Now draw a line vertically downward and do the same for point C. Let's say it has come to rest in this point. Now if we draw the points all together in the body, we'll get sorry, I have made a mistake. The three lines will intersect at some point. All the three lines will intersect, and that point of intersection will be your center of gravity for the irregular shaped body. So this is how method of balance works for a irregular shaped object. So this is all about your center of gravity and how to find the center of gravity. I hope you have understood the topic, and let's end this session here.